Problem for this morning. Grab a piece of paper and start on it.
No, I still have to sit there. I can't just go. If I could go, I would just go. I can't. That's so stupid. Sometimes you just sit there and do things, and you get up and walk and you wait. I'm anxious on this. Actually, it depends on who's there. Because some things are just that's easy versus or something like that.
Yes, absolutely. In other words, what you're saying is you convert diagrams into moles. Yep, absolutely.
formula that you need is on the board in the red, the green, and the purple, ladies and gentlemen. Now, you need to figure out which one you are trying to solve for, molarity, moles, or liters. And then you need to solve for the one that is missing. Please remember, anything that you are given in grams, you could easily convert into moles. If you're given grams and the substance, you can convert it into moles.
You do math. Figure out the math. Come on, this is just a simple algebra problem now. How do you get your variable alone to solve for it? Do mathematics. If nothing else, you know you want to get everything on one line so that you can solve for it.
All right, ladies and gentlemen, there are two ways to solve this problem. I'm about to show you both. Okay? But before we get into solving this, I would like to show you something. Okay? Something that we have been doing all along. All right. And what I mean by that is we have been doing conversion factors. We have said that if two things are equal to each other, we could take and put one over the other to make a conversion factor. So for example, ladies and gentlemen, 12 inches equals 1 foot. Because those two are equal to each other, we could take and we could put 12 inches over 1 foot, or we could put 1 foot over 12 inches. Now, the way we determine that, what unit are we trying to get out of? What unit are we trying to get into? We have been doing this since unit 1, okay? So anytime two things are equal, we can make a conversion factor out of them. And we can put either one of the units on the top with its number, either one of the units on the bottom. This would be used if you were going from feet into inches. This would be used if you were going from inches into feet. Are there any questions on that? Now this is easy because these both measure what kind of measurement? Do inches and feet both measure? What? What kind of measurement do inches and feet both measure? Distance or length? Yes. So there are a lot of relationships within a certain kind of measurement. And that's what we have here. We could talk about 12 inches equal to 1 foot. We could talk about 3 feet equal to 1 yard. We could talk about 5,280 feet equal 1 mile. All of those measure length or distance. Now, what we've got with molarity is a relationship between two otherwise unrelated terms. Molarity is moles over liters. Okay? So it relates the two quantities of moles and liters. And what we have is we have this kind of the opposite of what we had here. We already have a fraction. So what I have told you is we could take that fraction and we can think of it as so many moles equals 1 liter. Why? Because then if I want to, I could put liters on top over moles. Now, this would allow me to get out of liters and into moles. This would allow me to get out of moles and into liters. Again, it's conversion factors like it was here. The only difference is we're relating two things that otherwise normally wouldn't be related. We're relating moles and we're relating volume. That you can't look up in a book. That you cannot find in a handbook. They are not within the same type of measurement. But molarity allows you to do this. Now, what I didn't do a good job of stressing to you yesterday is this formula over here, ladies and gentlemen. This can be used to find a molarity, the moles over the liters. And that was some of the problems we were working yesterday at the end of the hour, and I'm going to give you some time to go back and work on some in a few minutes. You could find a molarity given this information. But if you have a molarity and one of these two, you can use that information to find the other. So if you're asked to find a molarity, they have to give you the moles and they have to give you the liters of solution. Now, they may give you moles in grams, as I did in the last problem. That is not a problem for us. You should be able to easily go from grams into moles. Okay? Now, the thing is, you've got to ask yourself, am I using molarity to get from one unit to another, or am I calculating it? Well, if they give you an actual molarity, you're using it to get from one unit to another. Two ways to do that. Let's take a look at both of them right now, ladies and gentlemen. Let's take a look at both of those ways right now. So, Here's my problem. The first way I'm going to do this is I am going to use this formula exactly as I have it set up right here. Exactly as I have it set up right here. But the first thing I need to do with this problem, no matter what, is I need to take this 83.6 grams of sodium carbonate. Formula for sodium carbonate, Jesus.
Na2CO3.
Na2CO3. And I need to get it into moles. So I'm going to put 1 mole on top. I'm going to put the formula mass on the bottom. Landon, what did you get for the formula mass for sodium carbonate?
105.98.
0.998?
88.
Thank you. Good. Grams and grams will cancel, and I will be left with so many moles of sodium carbonate. Elsa, did you get the moles of sodium carbonate? Katie, did you? Who got the moles of sodium carbonate for me? Alicio. 768? So I'm going to put 4 sig figs 0.7888. Okay? Not my final answer, so I just want to keep some sig figs. Moles of Na2CO3. So now what I'm going to do, ladies and gentlemen, is I'm going to go into that formula I have over my shoulder on the board. I'm going to put 7.12 molar equal to 0.7888 moles over X number of liters. All I have done is plugged in all the information that I have been given into this formula. That's it. Now I'm going to solve it. Now it is a mathematical problem. It is a mathematical problem where I am solving for X on the bottom. So what I am going to do, ladies and gentlemen, to solve for X on the bottom is I am going to do math. I'm going to take this side times X liters to get this to cancel out. And what I do to one side, I'm going to do to the other. Now I'm going to take and rewrite this X liters times 7.12 molar equals 0.7888 moles. And now what I'm going to do, ladies and gentlemen, is I am going to get that X alone. And I'm going to do it by dividing both sides by 7.12. All I'm doing is mathematics, ladies and gentlemen. This is algebra. This has nothing to do with science. This is algebra. I am isolating a variable. I got it off of the bottom, got it onto the top. Now I'm getting it alone by dividing both sides by the 7.12 molar. Divide this side by 7.12. What I do to one side, I'm going to do to the other. This cancels and this cancels. X liters equals, somebody take 0.7888 divided by 7.12 and tell me what we get. What was it again? 078? Okay, so I'm going to put 0.011. I'm now in 3 sig figs, which is what I want. I'm in the unit of liters. The problem, though, asked me to put it in milliliters. So to put it in milliliters, that becomes 111 milliliters. Is there anyone who has any questions on what I have just done? How I've gotten my answer, what I did in any of our steps. Now's your chance to please ask. So I simply took a formula. I plugged the numbers in where they go into that formula. Here's my molarity. Here's my moles. I don't know the liters. I have then isolated that variable and solved for it. Questions? Absolutely, positively, 100% able to do these problems that way. I like to do them a slightly different way. Okay? slightly different. Let me show you. The problem starts out the same. I still need to do this part of converting grams into moles. Have to. No questions about it. But now what I'm going to do is I'm going to take that moles and I am going to multiply it by a conversion factor. Now my conversion factor comes from this, ladies and gentlemen. My conversion factor comes from 7.12 molar is 7.12 moles of Na2CO3 equal to 1 liter. I'm rewriting it that way. I'm putting the two equal to one another. And now what I'm going to do, ladies and gentlemen, is I'm going to take this 7.12 and put it on the bottom here to get my moles to cancel out. Okay? And I'm simply going to put 1 liter on the top. I think that is much easier to do than all of this. I don't care which way you do your math. I'm going to get the same answer here that I did here because I'm taking 0.7888 and dividing it by 7.12 the same way I did here. I am going to get exactly the same answer because I am doing exactly the same math. But the power of thinking of this as a conversion factor is I can put whatever unit I want on top and whatever unit I want on the bottom. And I'm going to solve for the liters of solution here because they're the only unit that has not canceled out. This is going to equal, ladies and gentlemen, 0.111 liter, which still becomes 111 milliliters. This is not a problem where I am finding molarity. This is a problem where I am using it. And molarity, this is the link between grams or moles and volume. Okay? So if you are looking for grams, if you are looking for moles, if you are looking for volume, they have to give you a molarity. And they have to give you the other one. Here, since we're looking for milliliters, they gave us a molarity and grams. Grams is moles, or can be converted into it. And then this can get us from moles into liters. Questions? You got 3 questions on your quiz on Friday. 3 questions, 3 things in this formula to solve for. Shouldn't be that hard to figure out what the questions are going to be. Now, the problems that are at the back are still at the back, but I did take out the 5th problem and I changed it and I added a 6th one. Because when I looked at the problems, there were none that were like this, asking you to find the volume. So I made the problems that are in the back more similar to what you will see on the quiz on Friday. You should be able to do either all of the even or all of the odd problems. Because if you're doing all of the even or all of the odd, you're doing one where you solve for molarity, one where you solve for moles, one where you solve for liters. You have got, ladies and gentlemen, 25 minutes to go work on problems. Actually, 20 minutes to go work on problems. Then we are going to move on to the next thing. Yes, ma'am. You certainly can. Leave me your phone and go. Thank you. If you need help, if you have questions, please feel free to ask. Be more than happy to help you. Here are the problems if you choose to work on them at your desk. If you want to grab some scratch paper, again, maybe you did some of these yesterday, maybe you got 1 or 2 done. Again, my suggestion is to either do the evens or the odds. If you have time, go back and do the others. But if you do all of the evens or all of the odds, you will get a problem of each kind in there. One where you're solving for molarity, one where you're solving for grams, one where you're solving for milliliters or liters. Go to work, ladies and gentlemen. Who's solving? Double check before you this and everything. We have to do that. Into that formula. Or you do like you get type to where it's supposed to be. Hang on a second. There you go. I know for somebody I just took it away because somebody wanted to see all the copies, extra copies of it here if you want to see the problems. Or you could get one from the back station. And then you have any need to go to grant. This problem, you've got, what is that? Which is gimbals. That's which
There is no way for you to put 405 2.25. Say 0.2 times 0.45. Well, my guess is you divide it instead of what? Any questions? Questions?
All right, ladies and gentlemen, time to move forward here. So, for us to do that, we are moving on to the next thing. If you did not finish these problems, and if you wish to finish these problems, you have two choices. Choice number one, ladies and gentlemen, you can go into the Google or into Canvas under the daily agenda class videos. You can go to yesterday's agenda or you could go to today's agenda. Either one. When you open it up, here are the problems and the answers for you. They are there. You can get to them. You can practice them. You don't have to write them down. You can just do them. But again, the odds and evens, what your quiz is going to be on Friday. Questions. Okay. So take and open your EISN, ladies and gentlemen, and get to slide number 12, please. we are going to start talking about something called mass-to-mass stoichiometry. What that means, ladies and gentlemen, is you are going to begin with a mass of something, and you are going to be asked to find the mass of something. We're starting in mass, we're ending in mass. Now, again, starting in mass, ending in mass. Ethan! I'm teaching. Your headphones need to get put away. Thank you, sir. Okay? Anybody else who has headphones, please give me your attention now. Okay? So mass-to-mass stoich is the first and the simplest way. You are going to be given a certain mass of a reactant, and you are going to be asked to find the mass of something else in the reaction. So let's take a look at this, ladies and gentlemen. Here we go. If 40 grams of magnesium metal reacts with excess hydrochloric acid, how many grams of magnesium chloride will be produced? Hey, what do you know? This is your lab that you did. Except instead of asking you to find the volume of the gas created, I am asking you to find the mass of magnesium chloride that would have been created. Now, first step in these problems is we need to write out a balanced chemical equation. Which means, ladies and gentlemen, someone tell me how we would write magnesium. What? Mg. How would we write hydrochloric acid? HCl. Okay? So, MgHCl. Now, the products that we are going to create, you should be able to predict as well, because this is a single replacement reaction. And in a single replacement reaction, this lone metal will replace whatever is acting as a metal in this compound. Now, chlorine is a nonmetal. Hydrogen is acting as the metal here. So this magnesium is going to replace that hydrogen. Now, a couple of things. Things that we have been teaching you all along, but little things that will make a difference if you are not careful. If hydrogen gets kicked out, hydrogen is a diatomic, which means when it is alone, like it suddenly is on the product side here, you need to put a 2 by it. You do not put a 2 by it, you will not balance the equation correctly. Now, if you're wondering why, hydrogen has been on that list of diatomics that we gave you since we gave you the diatomics. And when hydrogen is alone, it will have a 2 by it. Magnesium is not a diatomic, that is why there is no 2 by it. Meaning, when magnesium kicks out the hydrogen, we get H2 gas. Now, magnesium is now with the chlorine. Why is there suddenly a 2 by the chlorine here? Magnesium has a charge of +2. Hydrogen in this compound had a charge of +1. Chlorine is a -1 in both of these compounds. So I am writing good formulas here. +1 and -1, 1-to-1 ratio. +2 and -1, 1-to-2 ratio. If you don't remember that, you better go back to it. Now, last thing. Metal, aqueous. Aqueous means dissolved in water. We know acids are always dissolved in water. This will be created as a gas. And then this will be aqueous because in a single replacement reaction, the compounds are always aqueous. Questions? Okay, so next we determine what we are given and what we are looking for. We are given 40 grams of this. That's what the problem tells us. Now, you do not have to do this, and you do not have to put it in there. But my recommendation is, after you write out this reaction, if you're given information about one of the reactants, you write underneath that reactant what you are given. I'm going to write 40 grams underneath here. Why? So that I know that is where I'm starting. Next, what are we trying to find? Well, we're trying to find how many grams of this stuff are produced. So I'm going to put a question mark by it with the G after it. G tells me I'm going into mass. I've identified what I'm given. I've identified what I'm looking for. Now we start our problem. We take what we're given, 40 grams. what is the first thing that we are going to do to it? Stoichiometry. Take what you're given, get it into moles. How do I get from grams into moles? Come on.
Mole over formula mass.
Mole over formula mass. 1 mole over the formula mass. This you've been doing since Unit 5. Absolutely nothing different here. Now this next step is the step that I'm going to introduce you to. Take what you're given, get it into moles. Step number 2, the molar ratio step. Molar ratio step relates what you are given to what you are looking for. Okay? What you are given to what you are looking for. By the way, I didn't point this out. Why is there a 2 in front of the HCl here? Okay, but why? To balance your chemical equation. There is 1 magnesium here. There is 1 magnesium here. There are 2 hydrogens here. Had to put a 2 in front of the HCl here to get 2 hydrogens here. There are 2 chlorines here. This 2 in front means there are 2 chlorines here. This is a balanced chemical equation. You do not balance it, you will not be able to do this next step. So for this next step, ladies and gentlemen, I am going to use a ratio step. And I am going to take the moles of product that I am looking for, magnesium chloride, over the moles of what I am in, which is magnesium. Now, where do I get the 1 from? What's in front of the MgCl here? MgCl2. What number? There is none, which means it's a 1. What number is in front of the magnesium here? A 1. If I had been using this, there would be a 2 in front. Okay? The balanced coefficients give you this molar ratio. They give you this molar ratio. So the molar ratio is what I'm going to on the top, what I am given on the bottom. Now, if you look, grams have canceled, moles of magnesium have canceled, and now I'm in moles of magnesium chloride. Step number 1, take what you're given, get it in 2 moles. Done. Step number 2, use the molar ratio. Done. Step number 3, report out in your final answer. What answer does it want your final number in? What unit? So how do I get from moles to grams? What grams on the top? The what? What do we call that? Formula mass. What's our formula though? Right, it's not Mg anymore. Here, I use the formula for Mg. Here, I'm going to use the formula mass for MgCl2. So, take what you're given, get it into moles. Use the molar ratio, report out in your final answer. All I need to do is do the math now. Now again, I am pleading with you. Do your math all at once. What I mean by that is, I have this entire problem written out and it is all unit cancellation. Everything will cancel now. Now all I need to do is figure out what to do with my numbers. Here's what you do with your numbers. You take all of the numbers that are on top, which includes this 40.0 grams, and you multiply all 3 of them together. Now, do I need to multiply by ones? No. So in reality, I'm going to take 40.0 grams times 95.21. I would take out your calculators now and I would try this, ladies and gentlemen. And then I'm going to divide it by. Now, there are 3 numbers on the bottom, right? But 2 of them are what?
Ones.
You need to decide right now. Are you going to put those ones in there or not? If you're not, you do not need to put this number in parentheses because you're only dividing by 1 number. If there is more than 1 number here, they would both need to go in parentheses and you would need to multiply them together. So 40.0 times 95.21 divided by 24.31. What do you get? 156.7. Now, sig figs. How many numbers are up in the problem above? 1. How many sig figs? How many do you think go in your answer? 3. That's it. That is mass to mass stoich. You take what you're given, you get it into moles. You use the molar ratio step. You convert out into the unit that you are expected. Now, a couple of things, ladies and gentlemen. This molar ratio step. I want to point this out to you so there is no confusion. The bottom of this here comes from what you're beginning with. Okay? The top of this here comes from what you're going to. That's how I determine that. That's how I figure that out. Since there is no number in front here, that means that that becomes a 1. Since there is no number in front here, that means that becomes a 1. That is where this entire ratio step comes from. Here and here. Questions on that? Yes, no, maybe so. Okay. Determine the mass of copper needed to react completely with a solution containing 12 grams of silver nitrate. Copper has a +2 charge in the compound. Okay. So let's take and let's write the balanced chemical equation to begin with, ladies and gentlemen. Do a little bit of reviewing here. All right. Denaya, how do I write copper metal? Cu. Because it's a metal, I'm going to put M by it. It is going to react with a solution containing 12 grams of silver nitrate. Silver nitrate. How do I write silver nitrate, Natalie? AgNO3. Ag +1. NO3 -1. The compound needs to be balanced off so that their charges are 0. Okay? If it is a solution, what 2 letters should I put by it? AQ. Okay. So now I'm going to produce something. All right. What is going to change places with what in this reaction, Parker? What 2 things are going to change places in this reaction? Ag and Cu. Cu and Ag. They are going to switch spots, ladies and gentlemen, which means Ag is now alone as a metal, and copper goes with the NO3. But now look at the note here. Copper has what charge to it? +2. You would have no way of knowing copper's charge by looking at the periodic table. So I have had to give that to you. What is the charge of NO3 still? -1. That doesn't change. So what would the formula look like? Okay. Single replacement reaction. A metal and aqueous produces a metal, and what would this compound be? Aqueous. Good. All right. So now, ladies and gentlemen, determine what you're given. Okay? Determine the mass of copper. Where's copper in this reaction? In the front. So ultimately, ladies and gentlemen, I am looking for the grams of copper. That is what I'm going to try to find. By the way, I'm going to back up here because what didn't I do to this reaction? I did not balance it. Thank you. I did not balance it. Cu, Ag, NO3. Copper on the reactant side. How many, Morgan? How many? I'm sorry, if you said something, I didn't catch it. I'm sorry. 1? Thank you. How many on the product side? 1. How many silver on the reactant side here? Silver on the reactant side here, Jalen? 1. How many on the product side, Jalen? 1. Now, NO3 groups, I'm leaving them together. I taught you that trick. We can do that because it's NO3 on both sides. On this side, Giselle, how many NO3 groups? How many on the other side? 2. Thank you. So now the only thing I need to balance is the NO3 groups. So Linda, how do I balance off the NO3 groups? Which side needs more? The right or the left, the product, the reactant, however you want to describe it. The left. So here's the NO3 on the left, right? So what number do you want me to put in front here? Let's put a 2 in front here. That will give me now 2 NO3s, but it also changed what, Linda? It did, but what else changed with this 2 in front here? The Ag is now how many? 2. Okay, so what do I do to finish up here, Linda? In front of the, which one? Thank you. Perfect. Put a 2 in front of the Ag on the right, ladies and gentlemen. Now everything is balanced. Questions? Wonderful. So now, ladies and gentlemen, let's finish up with what I started. I'm looking for, in the end, to know the grams of copper. What am I given? What number am I given and what is it for? Daniel. In this problem, I'm given a certain amount of something. What am I given the amount of? How much? Perfect. Okay, so now I have everything I need to solve this problem. I want to go from grams of AgNO3 to grams of copper. So I'm going to start out with my 12.0 grams of AgNO3. Now, what is the first thing I'm going to do to this, Wendy? I'm going to take what I'm given and get it into. Okay, so how do I go from grams to moles, Wendy? One mole of AgNO3 on the top. What mass, Wendy? What do we call that mass? I'm not asking you for the number, just the name. Well, we call that the what mass? Someone help her out, please. That's called the formula mass. Okay? So our formula is AgNO3. 1 times what's the mass of silver, ladies and gentlemen? 107.87? Yes?
Yeah.
Plus 1 times the mass of nitrogen, 14.007. Plus 3 times the mass of oxygen, 15.999. Someone add that up and tell me what we get.
169.874.
Thank you. Grams of AgNO3 cancel. Okay. Our next step, we've taken what we've given and we've gotten it into moles. Our next step is our ratio step. What goes on top of our ratio here? What goes on top of this ratio, Jesus? 1 mole of copper. Woohoo! Christmas comes early sometimes. Yes, Denia, what can I do for you?
What about that? Is there 2 on that side?
That 2 on that side.
Doesn't that make it 2 coppers?
Well, what's in front of copper on the left side over here?
Nothing.
Then that's why I'm putting 1 there. That's the copper. This is what I'm trying to find.
But wouldn't you put 2 in front of that?
Why would I put a 2 in front of it?
Because isn't it copper on 2 copper on the product side?
Where do you see a 2 in front of any copper on the product side? And I don't care about copper on the product side because I'm not going to that. I'm going to this stuff right here. This is what I'm looking for. So my ratio involves what I'm in and what I'm going to. I don't care about anything over here tonight. Nothing over here matters in this problem. It's about this and this. What number is in front here? So that's why I put 1 here. Okay?
No, it doesn't have 2 on the product side multiplied to the copper on that side.
It's just the
This 2 here?
No, the one on the product
This one here?
isn't it multiplied or not?
No, only what's in parentheses.
Oh.
And even if it doesn't, I don't care about this. All I'm worried about is this right here and the number that's in front. Okay? Hang on. Don't start putting away yet. I got 2 minutes left and I can get this problem done. All right. So this is what goes on the top. What goes on the bottom here? What goes on the bottom? Somebody help me out quick. 2 moles of AgNO3. Why a 2 in front? Because of that right there. Taking what we've given, gotten it into moles. Ratio, what's our last step? What unit do I want it in? Grams of what? So 1 mole of copper on the bottom. What's the mass of 1 mole of copper? Moles of AgNO3 cancel out. Grams canceled out here. Moles of copper canceled out. I am left with this. Someone, carefully with a calculator. 12.0 times 63.55 divided by parenthesis. 169.874 times 2. Close the parenthesis and hit equal. What? Anybody else get that? 2.244 grams of copper. The only thing I will tell you, 3 sig figs. Shania, I don't worry about the little numbers on the bottom here when I'm doing this ratio step. The only, if there were a 2 in front here, we already balanced that out. We already did that. We already did that. Why would you think that 2 goes to anything other than what's in the parentheses when it's outside the parentheses? Mathematics. If there's a number outside of the parentheses, it only goes to what's inside, not everything. Thank you. Thank you.
Thank you.
Yep. Goodbye, goodbye, goodbye. Thank you. Thank you. So, Denia, we already had balanced this.
Yeah, but what I was thinking, if that
This 2 only goes to what's in the parentheses.
I thought it went to the C.
No. The number in front goes to everything.
Oh,
The
yeah,
number
okay.
outside the parentheses only goes to what's inside the parentheses. Okay?
Mhm.
All right, good. Go away.
Yep.
Take a seat, Saphir, wherever you'd like, and let me know what you need from me, okay? All right, I will be back in just a minute.